So for example 1, it says graph the function f of x is equal to x squared for the domain -2 to 2, meaning we're going to look at this graph just between, on the left side, -2, and then everything in between up to +2. The graph of g is obtained from the graph of f, the transformation of 3 units down. So how are they related? Let's first look at the graph of f. All right, so if we take a look, it says you can use the slider to compare a point along the graph of f. So the blue is the graph of f, which is just f of x equals x squared. Um, and then I'm just going between -2 and 2. We'll actually learn how to graph a quadratic when we get into the unit on quadratics. Right now, we're really just looking at like, what's the difference between moving something 3 down. If I move something 3 down, look, to compare the f function and the g function, the x values are the same, right, as I slide this. But if you notice, the y value of the g function in orange compared to the f function in blue is exactly 3 less. So up here, again, the x coordinates are the same. The f functions are 3 different, specifically g, 3 less than f. If I move it anywhere, same thing. Here it's a little easier to tell. The y value for the blue is 0. The y value for the orange is -3. And everywhere in between, it's exactly the same. If you actually subtract it, 1.69 minus -1.31, that is, again, a difference of 3 all the way up here. 4 minus 3 is 1. So again, a difference of 3. That's called transformation. Transformation, I'm sorry, it's a translation of 3. A translation like this one is a particular kind of transformation of a function, one that shifts each point on a graph the same distance and direction. Other kinds of transformations, you kind of reflect across the x-axis, you can stretch and compress. We'll talk about what those things are and how that would work. But for this specific kind of transformation, it's called a translation because it just moves it exactly the same amount all the way across. In this case, what it's talking about is that k value, the number outside the the function. So g of x is equal to whatever f of x is minus 3 because everything went down 3. Okay. All right, let's go to the next part. All right, so graph the function f of x equals x squared for the domain -2, 2. So exactly how the other one started. The graph of g is obtained from the graph of f with a translation 3 units to the right. How are the equations, domains, and ranges of f and g related? Okay. So the only thing that's different about part B compared to part A is instead of 3 units down, the g function is 3 units to the right. So here again, we can see the exact same f function that we had in the last part of the example. The g function is 3 to the right. So every point is 3 to the right. Notice how here, it's the y values that are the same, but it's the x's that are different. So that means when I move horizontally, it affects the domain, not the range. On the last one, when we moved it up or down, that affected the range, not the domain. Very specifically, what's happening with this one is the adding 3 is on the inside. Okay. Um, let's take a look at the next one. All right, so part number 1, try it, part A. So at this point, I would pause, give it a try, and then you can see, my explanation. You can also check the answer in the digital text. All right, so it says, how did the transformation of f of x equals x squared to g of x equals x squared minus 3 in part A affect the intercepts? Well, it affected the intercepts by, well, the y-intercept specifically moved down 3, right? Uh, so the y-intercept of the f function is at 0. The y-intercept g is at, so that minus 3 specifically moved the y-intercept down 3. So I'm going to type that part in. The x-intercept also changed, right? For the f function in blue, the x-intercept is also at 0, just like the y one was. When you move the function down 3, it moves the x-intercepts out to the left and to the right. So it changed the x-intercept in 2 ways. Well, first, it went from 1 x-intercept to 2, and it moved it, 1 negative, 1 positive. If that minus 3 was minus 4, it would move them out even further, right? So the bigger the amount that you're subtracting would change it. If that was a plus and the orange function was moving up, there would be no x-intercept at all. So that would have an effect there. So I would say the x-intercept changed. Again, it changed in the way that I just described. It went from 1 to 2, and one's negative, one's positive. And when I hit check answer, it's basically saying that, right? The y-intercept went down 3. The original f function had 1 x-intercept, now it's got 2. Okay, let's take a look at the last one. So again, I would pause now, try it, see if you can answer the question, and then hit play and see my explanation. And again, you can hit your check answer and get that explanation there as well. How did the transformation of f of x equals x squared to g of x equals x minus 3 squared in part B affect the intercepts? So notice how in this one, the 3 that you're subtracting is inside the parentheses. Again, how that's going to affect it is it's going to move it either left or right instead of up or down. The left or right, well, in this case, the y-intercept for the original f function is 0. For the g function, since we're only looking at it on the domain that we are, now there is no y-intercept. So I'm going to say there is no y-intercept of x. The x-intercept was 0, and now it's positive 3. All right, so by subtracting 3 on the inside, the x-intercept is now positive 3 instead of 0. So okay, let's check our answer and make sure we're good. So the x-intercept translated right 3 units, so that's the 3 that I was talking about. And f had 1 y-intercept at the origin, and g does not have a y-intercept now, so same thing. All right, so that's example 1.